The overall goal of this procedure is to fabricate a skin-like electronic device for quantitative cutaneous wound management. This is accomplished by first developing an electronic device on a carrier substrate. The second step is to prepare an elastomeric membrane to embed the electronics. Next, the fabricated electronics are retrieved from their fabrication compound and transferred onto the membrane. The final steps are to enclose the electronics with a silicone coating and connect a flexible cable for data acquisition. The completed device is laminated near the wound tissue of a patient to monitor time-varying temperature and tissue thermal conductivity as wound management.
The main advantage of this device over existing tools based on microscopic visual inspections is that it can provide multifunctional quantitative monitoring of temperature and thermal conductivity near the wound tissue.
The soft, biocompatible, and skin wearable device provides the functions and characteristics for the use in the clinical settings, and it has a great potential to address important issues in chronic wound management.
This spin coating protocol can be performed on silicon wafers of any size. To begin, degrease the wafers with acetone and isopropyl alcohol. Then, rinse them in deionized water and dry them under nitrogen. Dehydrate the wafer for